Hello, my favorite team of programming enthusiasts. This is a video about intermediate drawing. Not 100% sure why I called it intermediate drawing, but really I just want to talk about a few extra features of drawing with P5 that will come in handy when you're trying to do stuff. So yeah, without further ado, let's look at these a couple of ideas. The sort of main things I want to talk about is how to manage the fact that when we apply styles to our shapes, so colors and line colors and those sorts of things, how we can avoid cross-contamination between different shapes because those instructions affect everything else. And then I also want to look quickly at transformations. How do we rotate shapes? Most importantly, because rotation is super fun. Okay? So the first thing I want to point out is just that when we use things like fill and things like stroke and things like stroke weight, for instance, and we apply them to a shape, so let's draw a rectangle at 100, 100. That is 100 by 100 pixels. So these are all things that control the appearance of the shape that follows them, right? So if I look at this in my browser, I see a red rectangle with a cyan stroke around it, and the stroke is 10 pixels in width, and that's because of those styling commands. The issue is, and we know this, all of these styling commands are now going to stay active for the rest of this draw function unless I change them to something else. So if I, for example, set the fill to blue, and I draw another rectangle next to the other one, 300, 100, so 200 pixels to the right, same dimensions. This fill is going to change because I set it now to blue, but the stroke, cyan, and the stroke weight, 10 pixels, they're going to still be active, and they're going to affect this rectangle as well. So we have our blue rectangle, but it still has a big cyan line around it. That's completely fine, and if that's what we wanted, then there's no issue here, right? But it's very often the case that we think of the different shapes that we're drawing as being independent from one another, so that this rectangle is completely different from this rectangle, and I don't actually want all of the extra stuff that's being applied here to apply to my new rectangle. I just want to start fresh. One solution to this is that we could just explicitly set everything back. So I know that the default stroke is black, so I could set the stroke to black to make sure that it is. And I know that the default stroke weight is 1, so I could also set that back. And this would restore the default settings that I changed up here, and then we would get maybe what we would expect, which is now our second rectangle is independent of the first. It's blue, it's got a black stroke that you can't see because of the black background, and it doesn't have a 10 pixel stroke width. Actually, let me change the background to 255 to prove that that's true. Yeah, so you can see it's just a 1 pixel black stroke around this square here, which is the default. That's fine, but this, you can see this could get really out of hand. If you apply a ton of different styling to one shape, then you're going to have to undo it all manually with your next shape, and with the next shape, and with the next shape. And it's going to be really hard to keep track of, especially if you end up moving things around in your program. And so there is a better way. And the better way is, instead of explicitly resetting things, whenever we want things to be independent of one another, we use a command or an instruction called push at the start of our styling instruction. So we push before the styling instructions, we draw our shape, and then we say pop. Now what does that mean? Well, what the push is saying is it's saying save whatever the styling situation is right now. Like if there's a style that's applied right now, save that, and we know that because we haven't applied any style prior to this push, it's just going to save the default settings, right? The fill is white, the stroke is 1 pixel, the stroke is black, etc. So this will save those settings, then we change them, right? We're changing those settings to be the things that we want to apply for our rectangle. We make the fill red, we make the stroke cyan, we make the stroke weight 10, we draw a rectangle and it has these things applied to it, and then the pop, which we do at the end, restores the settings that we saved with the push. So basically in this instance, it restores the defaults. So the fill goes back to white, the stroke goes back to black, and the stroke weight goes back to 1. That means that when we get to this rectangle, and we draw it, none of this stuff that we had done for the first rectangle will be applied anymore. We'll be back to the defaults. So we get that same effect, right? It's just that this is a much nicer way of doing it because we don't have to remember to change everything back. It's also the case that once we start doing this, it's a very good idea just to surround all of your shapes with these sorts of styling instructions with push and pop, right? Now this push and pop here, these two here, they didn't really make a difference because there was nothing afterwards to protect it from, but we might write something afterwards. And so generally speaking, let's surround our shapes and their coloring instructions with a push and a pop to keep them all nice and independent from one another. Perfect. So that's the first thing. That's push and pop. We put them around our shapes and their styling to keep those things independent of each other. That just allows us to have that little bit of extra control over our drawing. The other thing that I want to talk about quickly is the idea of transformation. So currently when we're drawing our shapes, we specify exactly where to draw them. They get drawn there at the size that we told them to be drawn, and that's it. But there are a couple of things that we almost always think of wanting to do, and probably the biggest one is that we would like to rotate shapes. It's just something that it feels like you should be able to do, and it also feels like something that could be super fun to play with if you could, for example, animate it or control it with the mouse or something, right? So we can do that. P5 in the reference has a whole section on transform functions. I encourage you to go and look at it. For the moment, I'm just going to talk about what we can do here. And the first function that I want to look at is really the fundamental one, and it's called translate. And what the translate function does is it moves the origin point, which is quite a weird concept. So if we go back to just drawing a couple of rectangles, and we'll just do the simple version of this. So if I draw a rectangle at 0, 0, that's 100 by 100, and it's red, right? We just filled it with red and we drew it. So that looks like a rectangle in the top left-hand corner, which we would expect because it's being drawn at 0, 0, and we know that 0, 0 is at the top left of our screen. What translate does is it moves where that 0, 0 is. So the way that we write it is we write translate, and then we specify how far we want to move it on the x-axis. I'm going to move it 200 pixels positive, so it's going to move to the right. And how far we want to move it on the y-axis, I'm going to move it 100 pixels, which is down. And that is going to move where 0, 0 is on my canvas. Now it is 200 pixels further to the right and 100 pixels further down than the top left corner. So then let me fill this one as green, just to live dangerously. And I'll draw a rectangle, and look, I'll draw exactly the same rectangle. I'm going to draw it at 0, 0, and it's going to be 100 by 100, right? So the only difference is the color. These rectangle instructions here are the same. The difference is the color and this translate. If we go and look, we see that the green rectangle is being drawn in a completely different position to the red one. The red one was drawn at 0, 0, when 0, 0 was the top left, but then we translated 0, 0, this origin point, by 200 pixels to the right and 100 pixels down, so that when we drew the second rectangle at 0, 0, it ends up being drawn here. And that is literally, that's what translate does, okay? Even though they're both being drawn at 0, 0, we can use translate to change where that is. On its own, it might not be that useful, but let's persevere for the moment because we do need to use it for rotation in a moment. One important thing to realize is that translate is not moving the origin to this location. It's adding this amount to the position of the origin. So for example, if I draw another rectangle after this and I translate by 0 across and 200 down, and I'll make this one a blue one, I suppose, for completeness, and I again draw a rectangle at 0, 0, 100, 100, it's not the case that I translated to the position 0, 200, i.e. on the far left-hand side and 200 pixels downwards. I actually added this to this translation here. So this one moved the origin by 200 to the right, this one moved it by 0 to the right, so the cumulative effect is that it's been moved by 200 to the right. Again, this one moved the y by 100 down, this one moved it by another 200 down, so now it's moved 300 down when I draw this rectangle. And so the effect is this one's been moved. The blue one is now being drawn 200 below the previous rectangle because we moved it by 0 and 200. Okay? So it's additive. Now that additive property the fact that each time you use translate, it increases based on what it was previously, it's not always super helpful. And so, in fact, again, what we can do is we can use our good friends push and pop around all of our shapes. And push and pop apply to things like translation as well. So by doing push and pop around every single shape here, what I'm saying is restore the defaults. That includes things like fill, but it also includes things like translate. So before this one here, we know that the origin is at 0, 0. Inside, we save that information as well as the fill and all of those sorts of things. And then we move the origin by 200, 100, but then when we pop, we restore it back to where it was at the top left-hand corner, which means that here, when we do it again, this time we are moving it based on the top left corner, so it's going to move down by 200. So when we look at that, we end up with the third rectangle is now only it's been moved not at all on the x-axis, and it's been moved 200 down, which is just exactly what the translate says inside its little set of commands. So push pop, I think you will agree, maybe makes it sort of behave in a more expected way. You can get some really interesting effects by not using push and pop and using the transformation instructions. I'll leave that to you to find out. There's some stuff about that in the too much information section of the notes for this video. Okay, so why would we want to do this? Well, I mean, there are reasons. You can do some interesting kind of drawing experiments based on moving the origin around. It's also true that if you want to work in 3D, then you have to use translate to move the origin around to work with 3D shapes. So that's a very good reason to learn how to do this as well. And there's some information about drawing in 3D in the too much information section as well. But in 2D, at least, the main reason that we might want to move the origin is because of rotation. So let's get back to a blank slate. And let's try using rotation. Let's rotate something without doing any translation. So let's think about drawing a rectangle, a red rectangle. Why not? We love red rectangles, don't we? I think so. And we're going to draw it in the center of our screen. So let's draw it in the center, which would be 250, 250. 100 by 100 makes sense. Okay, so that's a standard kind of, oh, and let's push and pop, I guess, around it as well, because we're good people who now remember to push and pop around our shapes. So fill of red, rect mode center, and draw the rectangle in the center of the screen, which is 250, 250. I could also use width over 2, height over 2, right, if I wanted to be a little bit more professional. And so that will give me my expected, look, it's a rectangle floating in the middle of the screen. Just because it's a little hard to see that that's in the middle of the screen, I'm going to change the background to 127. Oh, it's a bit dour, but there we go. So we have our centered rectangle. Now, if I want to rotate that rectangle, there is indeed an instruction called rotate. And rotate, we tell it the angle that we want to rotate the shape, any shape that we're drawing afterwards, right? So it's just like fill, just like translate, it applies to the shapes that come afterwards. So we say rotate, and then we give it an angle. The important thing to know here is that the angle that we give it is in radians, not in degrees. So you might be more used to using degrees in your life. So you say 45 degrees is kind of like a diagonal line, right? 90 degrees is at right angles to the horizontal. You can do all of those things with radians. It's just a slightly different numbering system. 360 degrees is a circle. In regular old degrees, in radians, it's 2 times pi. That gives you a full circle. So pi is 180 degrees, and pi over 2 is 90 degrees, pi over 4 is 45 degrees, etc. So if I wanted my rectangle to be rotated by 45 degrees, I could write pi over 4 like this to rotate it. Or I could actually write, if I wanted to, because there is a function that converts this, I can write radians 45, radians 45 like this. So this is using a little function called radians to convert the number 45, which is in degrees, into radians, which is what rotate is expecting. But for now, I'm just going to use pi divided by 4, because I don't mind radians. Notice that I'm able to just write pi in capital letters like this. It's another one of those built-in variable names in P5. This one represents the value of pi, which is 3.151. etc., etc. 3.14159. I used to know it to a few more decimal places than that. Okay, so looking at this, we would kind of expect to see, okay, well now our rectangle is going to be rotated by 45 degrees. It'll be in the center, but it will look like a diamond. It is not what we see. What we see is this, which is frustrating. So our rectangle was in the center, and now it's over here, which is very counterintuitive. Just by rotating it, it seems to have moved as well. So the culprit here is a little bit easier to understand if instead of just rotating it once, we animate that rotation. So I'm going to use an angle variable, which I'm going to make for myself. I'm going to start my angle at 0, so no rotation. I'm going to rotate my rectangle by the angle, so I'm going to say rotate, and then angle is going to be the amount that it gets rotated by. And I'm going to increase the angle of rotation every frame by a small amount. Let's say 0.01 to start with. Remember that, again, we're working with radians, and so 2 times pi is a full rotation, which is just like obviously 6.2-ish. So we don't want to add a big number here, or it will rotate too quickly. So the angle is going up by 0.01. And what do we see? I might need to reload this. I think my rectangle has vanished. There it goes, right? So you see it rotating. It is rotating, clearly, but what it is rotating around is the origin. So it's rotating around the top left corner by 45. Well, it was rotating around it by 45 degrees. Now it's just rotating in an animated way around that point. So if it's rotating around the origin, it's not really doing what I wanted. I wanted it to rotate around its own origin, not the top left of the screen. And we probably should know at this point that this is exactly where we would use translate, right? We want to move 0, 0, the origin of our canvas, to where we want to draw the rectangle. Then we can rotate it, knowing that it will rotate around the center of our rectangle, and then we can draw our rectangle. It's quite a to-do to get this to happen, but it is satisfying because it does work. So before we rotate, let's translate to width over 2, height over 2, which is the location of my rectangle. So that's going to move the origin, the 0, 0 point, to the middle of the canvas now. Now when we rotate, everything is going to rotate around the center, where we just moved the origin to. Now when we draw the rectangle, we don't want to draw it at width over 2, height over 2, because we've moved the origin to that position that we wanted. So we actually want to draw the rectangle at 0, 0, because that's the new origin, right? And then we get what we wanted, which is a rectangle rotating around its center. So we took the origin, if we begin from the beginning here, we took the origin, which was at the top left, we moved it to the center, which is where we were going to draw our rectangle. Then we applied the rotation, which is increasing over time, and then we drew our rectangle. And the rotation is being applied to it every frame, and so we perceive it to be rotating. That's how it's displayed. Obviously, there are things like the more we increase the angle per frame, if I change it to 0.2, the faster the rectangle spins. If I add a really much bigger number, it's rotating super fast now. It gets that kind of weird car wheel effect where it starts to maybe appear to move backwards or something, depending on what I do here. That's quite sedate and satisfying there. So that's what we basically most often, I guess, and again, there are different ways that you might want to rotate things. You might want to rotate things from an off-center position, for example, depending on what you're doing. I have an example of things orbiting each other in the too much information notes, for example, that you can achieve by rotating around, not around the center of a shape. But I think a large amount of the time what you end up wanting to do is rotate around a center. Don't be afraid to play with different configurations, but this is probably the most common thing you might want to do. And again, it's very important that we have our push and our pop around the whole thing so that none of this weird translation rotation stuff applies anywhere else in my program. It's just contained to within the push and the pop so that I can really have control over it. So we've got a spinning rectangle. That's wonderful. Just to very quickly add on, there is also a scale command. The scale command, which we can write like this, scale, allows us to change the displayed size of an object, right? So if I set the scale to 2, for example, by saying scale 2, just as you might expect, the rectangle is doubled in size. And you can even see that the stroke around it's a little tiny bit fuzzy looking because that's also been increased. It's been doubled in size, so now it is being displayed as a 200 by 200 pixel rectangle, still rotating because I left that instruction in there. If I scale it to 3, Now it's 3 times as big, quite impressive. If I scale it to 0.25, now it's a quarter as big. And again, you can see that the whole thing is being scaled. It's got really skinny lines around it. It's not that it's being drawn as a smaller rectangle, it's actually scaling the shape down to a different size, right? And of course, we could play around with the scale of our rectangle as well. I could make a variable for that. Notice that I'm making a variable called rectScale. I can't call my variable scale because that's already taken by the scale function. So you have to be very careful about things like that, right? This would be made much better if I stored my, my variables inside an object as properties. Then I could call it scale. But for now, let me call it rectScale. It's going to start as 1. Is it going to start as 1? No, it can start as 0. So the rectangle is going to be invisible to begin with, right? Because it's got a scale of 0. It's not going to be displayed. And I can make the scale increase over time as well by some amount. Let's say a small amount. We'll try 0.01 and see what it does. Nothing. Why did it do nothing? Because I foolishly thought it was called scale because I kept talking about it, but the variable is called rectScale. Very easy to get something like that wrong. Whoa. Okay, so it kind of zooms out from nothingness, getting bigger and bigger while it rotates because the rectScale variable is getting bigger and the rotation angle is getting bigger. And now we just have a red screen because the rectangle is so big that it fills the entire display area. Okay, so there's a couple more interesting tricks in the actual notes for this video, but that's really the basics of what I wanted to talk about today. First of all, push and pop are your very good friends. Most often you want to kind of put all of the styling and transformation stuff that you're doing to a shape, as well as the drawing instruction for the shape itself, inside your push and pop. That will keep everything separate from each other. It's much less likely that you'll have weird effects applying across your program. And then the transformation instructions like translate, rotate, and scale are a great way to kind of play around with other aspects of what could change in your program. Most importantly, remember that you need to translate the origin because things that you then rotate and scale are going to rotate and scale around that specific origin. So if you want something to rotate around its center, for example, you do need to translate to the position that you're going to draw the shape before you rotate and scale it. Okay? There's plenty more to play around with there, but that would conclude our wonderful, exciting, and satisfying intermediate drawing session. Thanks for paying attention. Bye-bye.